the Condorcert lecture. It's a great honor for me to introduce Szilvia Pápai, our 2022 Condorcert speaker. Can you hear me? It's a great honor for me to introduce Szilvia Pápai, our 2022 Condorcert speaker. Szilvia grew up in Hungary, attended Karl Marx University, probably called Milton Friedman University these days, earned her PhD from Caltech in 1995, taught at Koç University in Turkey, Notre Dame University in the US, and she has been at Concordia University in Canada since 2005. Szilvia has made fundamental contribution to our understanding of how to allocate discrete resources, what we call objects. Her most important work is a 2000 econometrica paper, Strategy-Proof Assignment by Hierarchical Exchange, where she addresses the issue of strategy-proofness for the classical object allocation problem. That's when a set of collectively owned objects have to be distributed among a group of people, at most one per person. Before Szilvia, we only had sequential priority rule. I don't know what metaphor to use here, but her paper opens the door to a smorgasbord, a cornucopia, a magic garden of new rules, many of which have reappeared in study after study since that 2000 date. Her paper has been a source of inspiration for countless others. I didn't ask, but I'm pretty sure that it's on the reading list of most of the people in this room. It has already collected 500 citations on Google Scholar, and it will collect many more. If you haven't read the paper, you shouldn't get dessert tonight. Szilvia went on to explore other aspects of the allocation of discrete resources, in particular when money is present, as in auction, and she has worked on coalition formation. In the last few years, her research has expanded in all kinds of interesting directions. We'll get a sample of this new work today. Examples are preference aggregation for couples, target priorities policy for school choice, balanced exchange in object reallocation problem when agents may own more than one. Much of it has been with graduate students at Concordia. She has indeed been very successful in attracting students to economic design. She told me she recruited 5 more last year, following 5 the previous year, and I have no doubt that we will soon have a Pápai School of Economics on the campus of Concordia University. Because she is Hungarian, I need to give you her Erdos number. It is 4. By the way, Szilvia, it's not by working with grad students that you're going to lower your number. One last thing, a little tutorial I want to give you on how to pronounce a name. It starts with an S and a Z, which is how you can tell that she's not Polish, because if she were Polish, it would start with an S, a Z, and a W, and perhaps another Z. As you know, Hungarian is one of the most challenging languages in the world. Only 10 million people have managed to master it, which is a little more than 1,000 of the world population. In case you are curious about what language is the easiest, the answer is pretty obvious. It is Chinese, since a quarter of the population of this planet seem to have no problem speaking it. So what the spelling of Szilvia suggests is that you should begin with something that's between an S and a Z. The S sound is easy. You have it in every language. The Z sound is also pretty easy, especially for French people. For instance, French people are very good at pronouncing the definite article in English. In fact, they are so good at it that you immediately recognize that someone is French when they say the table, the vegetable, the people. But creating a sound that's between an S and a Z, and between the S sound and the Z sound is not so easy because the Latin alphabet does not have a convex structure. It has an auto structure, and between the S and the Z, you have T, U, V, W, and X. And my Hungarian grammar tells me that any one of those 5 options is okay. That's the general rule. So in the application at hand, you would get Tilvia, Wilvia, Vilvia, Wilvia, and Szilvia. My favorite is Szilvia, so please welcome Szilvia Pápai to deliver our 2022 Condorcert lecture.
So thank you very much for this beautiful introduction, William, and thank you for the invitation. It's closer? Okay. Sorry. All right, so I start again. So thank you very much for this beautiful introduction, William, and thank you for the invitation. It's a great honor. First, before starting, I wanted to thank the organizers. So I only listed here the main organizers, but of course, as Mark just already elaborated on this, it's an impressively well-organized conference, and the organizers have been constantly organizing for the last 3 to 4 years. So I wanted to thank you as well. So thank you, David, Kanishka, Diego, Andre, Francisco, and Javier. And so now about my talk. So it's, as you can see, it's on targeted priority reserve policies. And it's a joint work with Dilek Sayed Ahmed, who is a PhD student of mine. And I also wanted to say, as William mentioned, so I have way too many projects going on at the moment. So I chose this one because, well, for 2 reasons. One is because I felt that maybe this is a bit more accessible to people who are not familiar with all the details of matching theory. And the other one is that it is very topical, and specifically, it has to do with EDI. I don't know if in your university the EDI, I don't know how to call it, craziness has taken over. At mine, it has. So EDI, equity, diversity, inclusion. Maybe you use a different acronym. So the paper has to do with these very worthy ideals, but of course these are also quite controversial, not just because perhaps not everyone agrees with these ideals, but also, so I got this from the internet. It's not my writing, it's just to motivate the talk a little bit. Of course the implementation itself is very controversial, right? So for example, EDI is responsible for me serving on a hiring committee in my department for hiring in financial econometrics, which actually made me, because of my gender, right? So I was the only available female in the department, and so I was forced by the vice provost to serve on the committee, which is not exactly, well, empowering for women, right? Because I was the only person who was really incompetent on the committee, as opposed to all my male colleagues. And then also, I hope I don't offend anyone by saying that EDI is responsible for me being up here today instead of a male colleague, but that's how it goes. So there's a lot of controversy around this. So basically, first, before I start, I wanted to say that the paper was not inspired by EDI, right? So we started this paper back in 2016-17, so it's a long time. So finally, we finished it. So the main inspiration for this was actually the Syrian refugee crisis and helping refugees. So just to put this in context. Okay. Oops. Okay, so let me tell you about the outline. You already see it. I will talk about priority reserves, give you a little bit of theoretical background, then about representation versus effective preferential treatment. I will introduce the Datpr mechanism, which is the deferred acceptance with targeted priority reserves. And finally, I will talk about the class of DA-SPR mechanisms, which are DA with sequential priority reserves. So to start, so we have reserved positions, which are, so you will be familiar with most of this, so I'm just giving sort of a general introduction, just in case. So these are reserved positions for a group that is to be prioritized. It could be underrepresented people, such as racial minorities, or the people in need of protection, such as, and this was our main motivation, refugees in emergency zones. Then people, or well, in this case, children, individuals prioritized by law. An example would be children living within a school walk zone. So what are the general aims of priority reserves? We can name quite a few. All of these will look familiar. Provide equal opportunity for the underprivileged. Give priority to members of groups who have suffered discrimination. Promote diversity. Affirmative action is a notable example. Provide help for groups that are in need, and among others, right, we could keep going with this list. Implement mandated priority rights. So our work actually originates with this excellent paper by Hoffalier, Jenmez, and Yildirim in 2013. So actually we set out to do something completely different from what this paper turned out to be. Which, yeah, maybe I can tell you about this later. But so we started with their paper because we wanted to look at well, multiple priority classes for refugees, and maybe have something like possibly, or maybe in a further project, in a later project, some dynamic features. But we ended up with just the same model as Hoffalier, Jenmez, and Yildirim, and this is basically because we couldn't understand their, their stability condition, which turns out to have an omission in the printed version. And so we were really puzzled by this. So we ended up working on their model and proposing a mechanism that would be a counterpart to theirs. So let me tell you first about their mechanism. So they proposed a mechanism which we refer to as DA-MIR, which is DA with minority reserves. And what it does, I will tell you the exact algorithm in a few minutes. But so basically, the idea, the reason, or one of the main results of the paper is that we can correct the efficiency problems which result from a previously proposed mechanism, which was just to put a cap on majority students. So basically, you just run the deferred acceptance. And for those of you who don't know what the deferred acceptance is, I will also give you the algorithm. But so you run this iterative procedure called deferred acceptance algorithm. And however, instead of just running it as you would normally, you put a cap on how many majority students can be accepted by each school. So if you have students and schools. But this turns out to be very rigid. So you can actually end up with wasted seats, empty seats, because you put this cap. And if the rest of the seats are not filled up, if you don't have enough minority student applicants, then if you don't fill it up, majority students couldn't have taken those seats. So the DA-MIR is a more flexible rule, which corrects this problem, and Pareto dominates the rule with the majority caps. Okay, so now I will give you the, as I told you, the algorithm. So this is more general than just the standard DA algorithm. So we call this DA with an entity selection rule. So instead of schools and students, our terminology is going to be entities and agents, because actually we are not thinking about affirmative action. We are thinking about, as you will see, more sort of targeted preferential treatment. Okay, so the DA with an entity selection rule. So this also includes the standard rule. It's an iterative rule. Each agent applies to a top-ranked entity in step 1, and each entity tentatively assigns its positions according to its selection rule. Now here, when I say selection rule, so this is also known as a choice rule or a choice function. If this is simply just taking the school's priority or preference rankings over the students, and you just take the top, whatever corresponds to the capacity or quota of the school, then this would be the standard DA. But clearly, if you want to use some sort of a priority treatment, then you have to have a selection rule, which is a bit more sophisticated and takes that into account. So any remaining applicants are rejected, and then we keep iterating this. So in a general step, each agent who was rejected in the previous step applies to her next ranked entity, and each entity considers the agents who are tentatively assigned to the entity, if any, together with its new applicant. So we refer to this as the applicant pool. So the applicant pool is always the agents who were already tentatively assigned together with the new applicants. And tentatively, and then From this applicant pool, it tentatively assigns its position according to its selection rule. So again, it uses that selection rule. Remaining applicants are rejected, and the algorithm terminates when each agent is either tentatively assigned to an entity or has been rejected by each entity that is acceptable to the agent, and then the agent is unassigned. So, and the tentative matches become the final matches in the last step. So HYY's Hauffaler-Jenmez and Yildirim, in short, HYY's proposed mechanism, the DA-MIR, is a DA matching mechanism with such an entity selection rule or a school selection rule, which is to implement affirmative action with a minority reserve policy. So let me introduce more formally, well, actually, I haven't introduced it at all yet. So let me introduce the DA-MIR mechanism. So it is a DA with an entity selection rule. So the selection rule is basically that first each school accepts minority applicants according to the school's ranking up to the number of the reserved seats. And then each school accepts applicants for the remaining seats, any applicant, it doesn't matter, again, in the order of the entity ranking. Okay? And the rest of the applicants, if there are any, are rejected by the school. Acceptances are tentative, right, because it's a DA with an entity selection rule. And then we keep iterating this. And so in step K, students who were rejected in step K-1 apply to their next ranked acceptable school. And the applicant pool, again, is the already tentatively assigned students together with the new applicants, and we select, the selection rule is the same as before. First, you fill the reserved seats with the minority students, if there are any, and then the remaining from all the from the entire applicant pool. Remaining applicant pool, I should say. Okay, so this is the DA-MIR. So if this is clear, okay. Then let me talk about representation versus effective preferential treatment. So basically, and by the way, so so I am going to talk about precedence orders, and this is not a new idea, as it turns out. We kind of reinvented the wheel, but what we are adding, well, among other things, what we are adding to this literature is this distinction between representation and effective preferential treatment. So we noticed, and so yeah, so this came out of the of this kind of little problem with the stability concept. So actually two things. One is that the HYY stability concept had a very important missing clause, and we were really not familiar with these stability concepts before. And the other thing is, well, we or I was kind of ignorant about what affirmative action is. So I thought that it really is about effectively helping, and of course that happens, you know, effectively helping minorities. But working with these stability concepts, I realized that it is actually about representation, right? So basically, what we did was, because we were so confused by the stability condition in Hauffaler-Jenmez and Yildirim, is that we at some point I said, okay, let's write down what we think this should be. And we wrote down a stability condition, and then later on, we were able to, we realized that we actually wrote down something not for representation, but for effective preferential treatment. So it's a different stability concept. Now, with this introduction then, let me give you this example. So I hope that everyone will be able to follow this. So I included these examples. So we have, so this is at the school level, right? So this is an entity selection. So we have school C, we have an applicant pool I1 to I5. The minority students are I4 and I5. We have one minority reserve, so one reserved seat for this school. And we have overall capacity of 3, which means 2 unreserved seats. And this is the school's ranking here. Okay, so here is the school's ranking. And so the DA-MIR accepts, first it fills a reserve. Oh, yeah, I see. Can you hear me? No.
Yes, not too bad.
I can actually yell, believe it or not, but well, not always. Okay, so I5 is selected first for the reserved position, okay, and then I1 and I2 for the two unreserved positions. Okay, so these are the selected ones. You can see on the screen. Yeah, so the selected students are indicated in red, and in bold I have the minority students. Okay, so now this is fine, but now consider another ranking for school C. So here, for the reserved spot, I5 is selected, and then for the two unreserved positions, we have I1 and I2. And so notice what happens here, that basically the minority reserve policy makes no difference, right? Because actually the top 3 students are picked, and the reserve position goes to I5, who actually would have been selected anyway without the reserve policy, right? And in fact, notice that there is I4, who on the other hand could make use of, of this seat, right? Of the, the reserved seat, the reserved position, okay? So now this is not to say that this is a bad rule, but what this tells us, what we discovered with quite a bit of work, I'm sure others would have gotten there faster, so what we discovered is that, is this too loud now? No, okay. What we discovered is that, so this is perfectly fine for representation, because if we wanted to make sure that there is one minority student matched to this school, then this is fine, right? But if we set out with the goal of actually matching someone to this school, a minority student who wouldn't have been matched otherwise, then this does not look very good, right? Okay, so in the DAMIR, the reserved number of seats may only be exceeded by the minority students at a school if the minority students are actually no longer prioritized by the school, okay? So this is an interesting fact, which of course it's completely consistent with representation, right? So effectively, right, so unless we have so many minority students who are highly qualified, which is probably not that likely in whatever real life scenarios, then actually this policy effectively puts a cap on how many minority students are accepted by each school, okay? So if representation is the main goal, then this policy works very well. However, if representation is not the main goal, however, we want some sort of a preferential or priority treatment which is effective, which makes a difference, then this policy doesn't seem appropriate. Okay. So the policy that we are proposing is what we call the Datpr mechanism. And basically, so we wanted to study alternative policies once we discovered what the DAMIR was about. And so we wanted to find a mechanism that actually helps, that can make a difference, right? Effectively helps agents who are to be prioritized, okay? So this is the deferred acceptance with targeted priority reserves mechanism. And so let me introduce this rule. So first, very quickly, the model. So the model is very simple. So yeah, so probably Gabriel wouldn't approve of it. But so it actually just partitions the agents into priority and non-priority agents. So we have a priority group and a non-priority group. We refer to them as priority agents and non-priority agents. And we have a finite set of entities, and each entity has a number of reserved positions. Oh, there is an overall capacity, and this is divided into reserved positions and unreserved positions. And then the agents have strict preferences over the entities and themselves. So this I is included there, E union I. So for those of you who are not in matching theory, so I stands for not being matched, right? So if you rank some entities below I, it means that those are unacceptable to you, okay? And for the entities, we actually have what's known as priorities, a priority ordering over the agents. But here we try to stay away from using the word. So these are not preferences, and there is a difference. So basically, this is the school choice model, if you are familiar with it. But we didn't want to refer to these as priorities because we didn't want confusion with the priority group, okay? So we just refer to these as entity rankings, okay? But so what's the difference? So what, I mean, it's not just a terminology difference between preferences and priorities. I should point this out. So when we have priorities, it means that we treat this side of the market, the entities, as non-strategic agents, and basically we don't, or we could even, we could say that these are objects to be consumed. So the axioms, for example, we don't have incentive axioms for the entity side, and we also, we don't care, for example, about welfare for the entities, okay? All right, so this is the model, and so here is so first, so both the DAMIR and DATPR are deferred acceptance mechanisms with entity selection rules. Yeah, I probably should have said all these earlier. Entities can be whatever, schools, countries, hospitals, firms, universities, and so on. The selection rule for each entity specifies a set of selected agents from each applicant pool, and different entity selection rules differ in their priority reserve policies, or, well, it could be much larger, of course, but we are focusing on priority reserve policies here. So what is the DATPR? So here is the definition. So again, it's a DA with an entity selection rule, and specifically, here each agent applies, so I should just tell you the selection rule. So basically here, we fill the unreserved positions first. So it chooses the highest ranked agents. It says N there, so maybe it's a bit misleading. So just from the applicant pool, but N is meant there to indicate that it's from the entire applicant pool. So whether priority or non-priority doesn't matter. So first we fill the unreserved positions. Then from the remaining agents, we choose the highest ranked priority agents to fill the reserved positions. And we call these targeted reserved positions because these are targeted to agents who haven't been picked for the unreserved positions, right? And then if any spots remain, then we can fill them, and clearly these will come from the non-priority group. Okay, so this may look more complicated than it actually is. And of course, it's an iterative rule, so we do the same thing in general. In step K, we use the same, right? First, we fill the reserved positions, then the reserved positions, and if any positions remain, then we fill that up. Okay, so now this, if you feel like you are not clear about what's going on, then hopefully this slide will make it clear, okay? So basically, and this is referred to in the literature as precedence order, okay? So, and this is not, something, I mean, we are looking at it in this very simple model, and there are more complicated papers and whatever, but so we are not the first ones to look at precedence order. So I will tell you what our contribution is here. So, but basically, just so you understand the difference between the two, so basically the DAMIR starts with the reserved positions and then fills the unreserved positions. However, so it's very important to note that if there aren't enough priority agents to fill the reserved positions, then we can fill them with any agent from the applicant pool. Okay, which is otherwise we would have that problem with wasting positions, right? And so the DATPR is the opposite, as you can see from here. So it starts with the unreserved positions, and then it fills the reserved positions. And so once more, so hopefully it's already clear, the intuition, what's going on here. But just to say, so at first glance, you might think that it's good to fill the reserved positions first, and then you can worry about the unreserved positions. But of course, as you hopefully already saw from the selection from the DAMI, I haven't shown you a comparison yet. I'll show you an example as well. So, but basically the idea is that the unreserved positions can pick up priority agents who would qualify on their own right? So they should not take up the reserved positions, and then, so once you fill the unreserved positions, which could go to priority or non-priority agents, then you fill the reserved positions, which, I mean, not in every case, but for the most part, will go to agents who would not have been picked otherwise without the reserved position. Okay? So if this is clear, is this clear? Yeah. Okay. Okay. So, oh yeah, so I should definitely talk a little bit about the literature. So we are not the first ones to study precedence order. So it turns out that in school choice design, there are these very practically minded papers, really good papers. The first one is about the Boston neighborhood or walk zone distribution. So basically, they set aside 50% of the seats in each neighborhood, for the walk zone children, and so on. And the other one is about Chicago school choice exam schools. So these two papers actually look at precedence orders, but what is the main difference? I think I didn't list all of this. So actually we were not aware of these papers, which is kind of shameful, but luckily our colleagues pointed it out. So, yeah, so we kind of reinvented the DATPR. But so what they are doing, they treat precedence order as an alternative means of changing impact, not as serving different objectives. So they are basically looking at kind of, statistically and theoretically as well, but just at the school choice level, at the choice function level, they are treating the precedence order as just a different means of getting, more minority students or whatever the context is selected by schools. So they are saying, on the one hand, we could reserve the number, on the other hand, we could just change the precedence order, and they have similar impacts. Or it can even be used as a kind of a politically, more palatable alternative, because maybe increasing the reserved seats, the number of reserved seats, would not be acceptable, but then you can go the other route, which maybe nobody will even notice, right? It's like, well, you are just tweaking your mechanism a little bit, you change the precedence order, and suddenly you are accepting more minority students or whatever the context calls for. So that's one difference, and then they only look at selection by individual schools, so what we call at the entity level, whereas we are focusing on entire matching mechanisms. And also we work with stability concepts. They don't. For us, it's very important. And also I should say that these are the papers that inspired us. So before we, it was actually pointed out to us, before we were told about these papers, we treated the DATPR as just a counterpart to the DAMIR, and we didn't think in terms of a whole class of rules. And then we read these papers, and we realized, oh, it's an entire class of rules, which would be really interesting to look at. And then we expanded our paper. So let me show you, hopefully this will really clarify everything about these selection rules. So I'm going to show you a comparison of these selections. So this is, again, it's just at the entity selection level. So we have our applicant pool, I1 to I5. We have priority agents, I4, I5. And the priority reserve, again, so it's the same setup as before, right? So we have one reserved position. We have overall 3 capacity, which means 2 unreserved positions. And here is the entity ranking. And so the DATPR chooses, so the DATPR, as you can see, so it starts with the unreserved positions, so it is going to select I1 and I5, and then for the reserved position, it picks I4. So what's the significance here? Oh. Okay. So what's the significance? The significance is that of this example is that you can see that 2 priority agents are selected, even though there is only 1 reserved position. But the reason for that is that I5 actually didn't need the reserved position, right? However, I4 needs it, and so this way we have 2 priority agents selected, and indeed we can say that the reserved position is a targeted position. It was targeted to an agent who would not have been selected otherwise. Okay, and then we have the DAMIR, and this is, I believe, yeah, this is the same example that you've seen before. So it starts with the reserved position, I5, and then it fills up the unreserved, right, I1 and I2, and this way the one reserved position goes to I5, who would have been selected anyway. Okay. So that's the comparison, and I hope that this is all very clear at this point, but please ask, yeah, so if you have any question. Yeah. So, okay, so the DATPR targets just a few comments, right? Just again, hopefully I'm not saying this too many times. I'm just, I want everyone to follow the talk. So the DATPR targets exactly those agents in the priority group who are in need. And it recognizes that not all agents in the priority group need preferential treatment. And this contrasts to the DAMIR, because the DATPR allows for a higher number of priority agents than the reserve quota set aside for them, without forfeiting the priority rights of the agents who need them. Remember that the DAMIR puts that effective cap on the minority students. And so we can see that strong priority group applicants can get accepted by entities on their own right without using up reserved positions. Okay. And so the, yeah, some potential applications. I don't know how I'm doing with time. Okay. So potential applications, the refugee settlement that I already mentioned, right? Refugee families from war zones or with emergency priorities. We could think of many examples, right? So I'm sure you could generate some, but just to mention a few: scholarship allocation for students from poor socioeconomic background, centralized job markets. We could have applicants with disabilities and so on. So I'm just trying to sort of, because, so sometimes we are really stuck in this mode of thinking about affirmative action, not me personally, because I didn't know that much about it, but I've noticed when talking to people, so that's why I'm trying to bring these examples. So you can see in these examples that there is no representation issue, right? So we are not going to say that, oh, we only, we want a certain number of Syrian refugee families, specifically. No, what we want is we want to help a certain number, right? So that's a different goal. Okay. So also, yeah, just to point out, so the DATPR is not just simply, this is sort of anticipating some questions already, which you may not have. But anyway, the DATPR is not just simply an intensified DAMIR policy. The two policies serve different goals: effective help versus representation. It is not appropriate if representation is the goal, such as with visible minorities, or if we have any issues with overrepresentation or underrepresentation, right? But you could see in those examples, we don't worry about, oh, we are going to have too many, disabled children or something like that on a scholarship, right? That's not an issue, right? So the number of the, this is also really important, actually, and I think I haven't really mentioned this before. So actually, let's start with the last point here. So the number of the reserved positions should be determined differently for these two different policies, right? So the, for the, if you want targeted, right, so effective priority treatment, then you should pick the number of the reserved positions according to how many agents should be helped. Okay, so for how many agents it should make the difference of getting accepted or not, as opposed to, for representation, right? If you are using, so this is for the DATPR, and if you are using the DAMIR, then you should be choosing that number according to how many minority students you actually want matched to that school. Okay, so this is a difference, right? How many you want to help versus how many you want matched, right? And so because of that, so if you think about it, so for example, if you are using the DAMIR policy and then you realize like, oh, but actually our goal is not representation. We actually want to do an effective help, right? An effective treatment, or well, we also refer to this as protection. Then you should think in terms of setting the reserves according to these objectives, right? And so what it means is that if you switch from the DAMIR to the DATPR, it doesn't necessarily mean that you are going to get more affirmative action, as some might fear, right? Because in fact, you might then want to adjust that number down, right? Because you anticipate, right, But I'm not saying it doesn't have to be changed, but it's just these are two different principles based on which you are going to choose the number of the reserved positions. Okay, and so presumably, yeah, you might want to actually adjust it down because in anticipating that. Yeah, so yeah, basically because you have a different goal. Sorry, I'm just rattling on. Oh yeah, so just sort of since picture is worth 1,000 words, so this is also of the internet. So presumably this is to symbolize diversity, right? So you can see all the different colors, right? And so what I wanted to show you, and excuse my artwork, clearly I have no idea how to draw a hand, but so the idea is that if we start from a picture like this, so notice there is no color. Now it doesn't mean that we just want one color and no diversity. It's just basically, it's like being color blind, so we don't care about the color. We are looking at the different heights of the hands, right? And so basically if we start from this, we want to go towards more something like this. I'm not saying that it should be necessarily complete equity, but we are working towards that goal of more equity, right? So I don't know if this illuminates anything more, but yeah. Anyway, so our main contributions are basically, we are the first to recognize that different priority reserve policies represent different goals, representation versus targeted preferential treatment. We study entire matching rules, unlike most of the literature that seems to focus on the entity level selection, that is the choice functions, but this is similar to Hoffler-Jemens and Yildirim. We use stability concepts, which is central to our analysis, and also we provide theoretical analysis of normative and incentive properties of different priority reserve policies. So now I'm going to show you our stability condition, the one that I mentioned earlier that we had written down, not necessarily in the correct form initially, but let me just warn you, so this is actually so these stability conditions, when we have a reserve policy, can get a bit complicated, okay? So it's not just that we are complicating matters, just to point that out. So so first of all, so the standard stability basically would just require individual rationality, which is what you see here, right? So each agent is matched. So if we have a matching mu, which is protection stable, so this we call our stability concept protection stability, each agent is matched to an acceptable entity or the agent remains unmatched, so individual rationality, I'm sure you all recognize it. And the second one is also a standard. This is non-wastefulness. It says that if an agent strictly prefers an entity to her assignment, then the entity should be filled to capacity, right? So you shouldn't waste seats. This is non-wastefulness, and now the standard stability condition here would just say that we should not have a blocking pair of the kind where we have, or actually here I should say there should not be justified envy, another terminology used in this literature, which would mean that we have this agent I, like here, who would prefer entity E to the matching mu I that agent I receives. But however, there is some agent with a lower ranking than this agent who is matched to that entity. So this would be standard stability, but now clearly, so this basically, it would enforce the exact entity rankings, right? And clearly here we cannot have that because we have this priority treatment policy where we are trying to give preferential treatment to the priority group. Okay, so that's why we need to have something more complicated. So first of all, so this I here, so we have to distinguish between two cases, whether I is a priority agent or a non-priority agent. So, so this is the I, so keep in mind from the previous slide, right? So this is the agent, right, who, so this will apply here. So this is the agent, agent I, who and entity E, such that agent I prefers entity E to mu I, which is the agent's assignment in matching mu. Okay. So now, but yeah, I think I'll sit down. So it's just easier to see. So. So now for agent I, who is in N+, that is the agent is a priority agent, we have the following requirements. So first of all the agents matched to E should be ranked higher by E than agent I. So this should make sense because so we keep the standard stability within group, right? Within the priority group and within the non-priority group. We don't violate the entity ranking. We don't violate the entity rankings that way. And also because these are priority agents. So basically, if the priority agent is not selected, then it should be the case that everyone who is selected has a higher ranking by the entity, right? And then the second condition is, I don't know how I'm doing with time. Sorry. Okay, so the second condition is that all reserved positions at E are filled with targeted priority agents who would not have been selected by E without the reserve policy. So this is the trickiest part of the definition. So let me explain actually the formal definition, and then you will understand this interpretation better. So this N plus E bar, right? This N plus E bar here. So this is defined as the set of those priority agents matched to entity E for whom all of the non-priority agents who are matched to E are actually higher ranked, okay? And so we can think of these priority agents as targeted priority agents, right? Because every non-priority agent who is matched to this entity has a higher ranking, okay? And so then we can say that this condition says that the number of targeted priority agents should be at least the number of the reserved seats. Okay, so this is different from HYY stability, which says that actually just the number of the priority agents should be at least the number of the reserved seats. So this is the number of the targeted priority agents. Okay, so so this is really important, and so we can interpret this as all reserved positions that E are filled with targeted priority agents who would not have been selected by E without the reserve policy. By the way, strictly speaking, it's not true because there's a little slippage there, but more or less this is the correct interpretation. So I don't want to get into some technical details here. Okay, so this is to enforce the priority reserve policy, and then for the non-priority agents, so they also have rights. Because we have a certain, so we are not giving we are not keeping all the positions as reserved positions. So of course we have a fixed number, and so the non-priority agents also have rights. And so here, if I, the agent who would like to have been selected by E but wasn't, is a non-priority agent, then first of all the non-priority agents who are matched to E are ranked higher by E than agent I. So this should make sense. Again, there is no priority violation within the group of non-priority agents. And also, the number of the priority agents matched to E who are ranked lower by entity E than I does not exceed the number of the reserved positions. Okay, so this is, and these are to ensure the rights of the non-priority agents. Just trying to keep track of the time. Okay. So, okay, so we are done with the stability conditions. So you can see it's a bit of a handful, but hopefully you could follow. So this is protection stability, and now I can show you finally a few results. So first of all, the DATPR, not too surprisingly, is protection stable, and also it is agent optimal with respect to the set of protection stable matchings. Agent optimality means that at every preference profile, the matching that is assigned by the DATPR it actually Pareto dominates all other protection stable matchings at that preference profile. Okay, and then theorem 2, we have also the DATPR has this very strong incentive property. It is weakly group strategy proof. Now, this is not too surprising, by the way. So the DAMIR is also weakly group strategy proof, I should say. And probably everyone in this room knows, but anyway, I'll tell you, yeah, actually, maybe it's not clear what's the weak and strong version, but I'm sure everyone knows group strategy proofness. So basically, a group of agents cannot manipulate in the sense that they report different preferences from their true preferences, and every one of the members of this group will be strictly better off. So this is this is ruled out, and so this is the weak version of group strategy proofness, which is also satisfied by the standard deferred acceptance algorithm. Okay, and finally here we have a characterization of the DATPR. So we characterize it just with protection stability and strategy proofness. Okay, and actually it turns out that we can also similarly characterize the DAMIR using HYY stability condition, which we call representation stability. Obviously, they didn't. And so we can say that representation stability and strategy proofness characterize the DAMIR. Okay, so any questions? No questions. Yeah, so now what I'm trying to show you is, so one might ask the question, so this would come up naturally, well, is it the case that the DATPR Pareto dominates the DAMIR for priority agents? And so the answer is no. And so those of you who work with the DA, you are familiar. So this kind of phenomenon pops up in many different contexts, that we cannot make this kind of profile-by-profile comparisons. And the reason is that we have, yeah, I'm going to, because I'm talking about this, I'll come back briefly to the example. But so basically, there are these rejection chains in the deferred acceptance. So if we change just one selection, that can cause a rejection chain, which then leads to odd things. So we can virtually never make these kinds of comparisons. So to some extent, it's not surprising. On the other hand, of course, it would have been nice to say that, okay, we can see that there is this kind of Pareto domination for the priority group, but this is not true. So in this example, for example, you can see, let me try. So here, I6, I7, and I8 are priority agents. And what happens is, so here, entity 1 selects I6 for the DATPR, whereas the DAMIR does not select. It selects I3, who is a non-priority agent. And similarly, you can notice here, I8 is selected a priority agent, whereas here, I8 is not selected by the DAMIR. I5 is selected, who is a non-priority agent. But now what happens? So this is all good, right, in terms of the comparison. So I6 and I8 are better off, who are priority agents. But now what happens is that, so here, I3 is rejected, a non-priority agent. And in the next round, I3 applies to entity 2. And here is I7, who in the DAMIR actually stays with entity 2. But in the DATPR, so this is that rejection chain that I was referring to, in the DATPR, I7 is rejected because of I3's application, right? And so I7 actually is worse off, who is a priority agent, is worse off with the DATPR than with the DAMIR. Okay, so just to give an example of this. So, however, what we can do, and this seems very limited, I admit, but still it is indicative of this kind of relationship. So we are using what we think of as a benchmark case. And basically, again, it's very restrictive. So the idea is not to say that this is realistic to have these homogeneous profiles. So what are these homogeneous profiles? So we will say that the agent preference profile is homogeneous if all agents have the same preferences over the entities. And we will say that the entity ranking profile is homogeneous if all entities have the same rankings of the agent. So clearly, a very restrictive case. But this is a case where basically we don't get those rejection chains, right? And so this shows the relationship that we were looking for, that if the matching is different between the DATPR and the DAMIR, then the DATPR weakly Pareto dominates the DAMIR for the priority group. Okay, so, and this is not an accident that this goes in this direction and not the other way. Okay, so now I'm ready to talk about the class of DASPR mechanisms. And so these are deferred acceptance with sequential priority reserves. So this is that class of mechanisms that we didn't realize existed until we saw the Boston and Chicago school choice papers, and they were looking at entire sequences. Well, actually what they were doing, they were just making these adjacent switches, which I will tell you why they are doing this when comparing sequences. So basically, we know that the DAMIR has all the reserved seats or reserved positions up front. The DATPR has them at the end of the sequence. But then we can also come up with just any arbitrary sequence, and that's another priority reserve policy. Okay, so we could have just, for example, here in this example, we have 3 reserved positions and 4 unreserved positions, and we could have a sequence which says URR, UU, So it means for every U position, unreserved position, you pick the highest ranked agent according to the entity from the entire replicant pool, and for every R or reserved position, you pick the highest ranked priority agent, if there is any. If there isn't, then you can take any one from the applicant pool. Okay, and you just keep going like that. Okay, so now we have another stability condition, and I'm not going to go into all the details. I think I can explain this fairly intuitively, quickly. So first we have, of course, the usual, so this is a weak reserve stability. As the name suggests, it should be a weak stability condition with priority reserves. So it has the standard individual rationality and non-wastefulness, and it also has the 2 conditions, which you remember, hopefully from protection stability. We have the condition for the priority treatment, right? And then which is for the priority agents, and then we have the protection of the rights of the non-priority agents. So these are 2A and 2B respectively. And what this does, it basically takes the weaker of the, so we have protection stability, which is the stability satisfied by the DATPR, and then we have representation stability, which is satisfied by the DAMIR. And so we are taking the weaker of the 2 conditions for these, from those 2 definitions. So those 2 are not comparable, because so the protection stability has a stronger requirement for priority agents than representation stability, and vice versa. Representation stability has a stronger requirement for non-priority agents. And so here for 2A, for the priority agents, we take the condition from representation stability, which is the weaker one, and for 2B, for the rights of the non-priority agents, we take the condition from protection stability. So hopefully, without going into too much detail, this illuminates this reserve stability condition. And the reason I'm presenting this is because this is what we use in our main characterization result. So we were able to show that a matching mechanism is weakly reserve stable and strategy proof if and only if it is a DASPR mechanism. Okay, so this class of rules is characterized. So this is actually quite interesting because weak reserve stability is really not that strong. Obviously, it's a stability condition with reserves, but it allows for all kinds of rules. So it's strategy proofness, right, which is very strong, that really narrows it down to just these sequential rules. Okay. And so now it's also true that the DASPR mechanisms are constrained efficient within the class of weakly reserve stable mechanisms. So constrained efficiency means that they are not Pareto dominated within this class. So there is no other weakly reserve stable matching at any preference profile that Pareto dominates the one that is prescribed by the mechanism. And also these are all weakly group strategy proof. Okay, all of these rules are weakly group strategy proof. Although in the proof, as it turns out, we didn't need, we only need strategy proofness. But now here is the question. So some of you are probably already thinking like, what does that mean? And you are right. So we asked the same question. So what does it mean if we have a policy which says, let's say, URR, UUR, UUU? What is the priority reserve policy? Can we explain that? And actually, if you think about it, well, not really. I mean, it seems like a very confused policy, right? Or at least, well, maybe somebody at some point will come along and explain to us. We couldn't. So, and in fact, so we are thinking, oh yeah, so I want to mention this. So in oh, sorry, I should have updated that. So it's 2020, it's now, yeah, it's out, it's been out for a while. Okay, anyway, so this is the Chicago paper. So they do this kind of what they call comparative statics. So they only switch to adjacent positions. And that's because, so basically we can't really make good comparisons if we just pick arbitrary sequences. But if we only switch to adjacent positions, we can make comparisons. So let me give you, a little bit on this. So basically, let's just pick two very simple sequences like URRU and RUUR. So now it's not too surprising, but just to sort of, illuminate this point with this example. So if we choose one entity ranking, let's say like the one given here, and I indicated in red the priority agent, so you can see right away. So URRU, so you can check, right? So if we start with U, it selects just the first agent, that's I6. For the two reserved positions, we take I7 and I8, two priority agents, and then for the last U position, we just take the highest ranked remaining agent, who is I1. So this selects three priority agents. Now for RUUR, we get I6 for the reserved position. For the two unreserved positions, we have the next two agents, I1 and I2. And then for the reserved spot, well, we have the next priority agent, I7. So notice the first one selected three priority agents, the second one only selected two, right? But now, if we switch, and this is not too surprising in a way, but it's just, it's kind of to say that there is a reason why we don't really know what these policies are saying, okay? So, or at least we cannot compare them easily. This is, it's more about that, but anyway, so if we choose a different entity ranking, then notice that the first one, URRU, picks two priority agents, and the second one chooses three of them, right? So here we have, maybe I don't need to go over this, right? So anyway, well, maybe, okay. So U is the first agent, and then for the two reserved spots, we have I6, I7, and then just the next unreserved, next agent in the list, I3. However, for RUUR, we pick I6 for the first reserved spot. Then we have two unreserved ones, so it's I1 and I7, just the ones that are next in the ranking. And then we have, for the reserved seat, we have I8. Right? So notice that this turned around. So for the first entity ranking, the first sequence chooses 3, and the second one chooses 2. And now, for a different entity ranking, the first sequence chooses 2 priority agents, and the second sequence chooses 3 priority agents. Okay, so, and this, I mean, it's not surprising in a way, but also we can see that we can hardly say which one would be kind of a stronger policy, right? So, yeah. So what we can do is we can say, well, let's take the cumulative reserved position count in the sequence. So for example, for the sequence URRUU, this would be, so we are counting the reserved position. We could count the unreserved, doesn't matter. Let's say we are counting the reserved positions, so then we have 0, 1, 2, 2, 2, right, cumulatively. And the second sequence here, URUUR, has 0, 1, 1, 1, 2. And so we can compare two of these sequences if one, right, if we compare these vectors, right, if one is less than or equal to the other, then they are comparable. And the one that is less, because we are counting the reserved positions, so the one that is lower is more targeted than the one that is higher. Because remember, the DATPR has all the reserved positions at the end, and that's the most targeted rule. Okay. All right. So yeah. So just So the definition. This is exactly what I just explained. So F and F prime are comparable if. Oh yeah. So this is I showed you at the entity level, and so now for the entire matching rule. So F and F prime are comparable if for all entities, right? We have this kind of comparability. And then we can say that if it is the case, so we also have to require that it always goes, the comparability goes in the same direction, right? Then we can say that one of these mechanisms is more targeted than the other. And this has to be true for all entities. Right? Okay. So so now, so what can we do with this? So basically, we are recommending the following. So instead of just sort of, I mean, so far at least we couldn't really discover what to do with just any arbitrary sequence. But however, we may want to compromise between our two objectives, right? So it could happen that maybe you don't want just entirely representation, or maybe you don't want just entirely targeting agents, right? So doing this kind of effective treatment. So instead, maybe you want some sort of a compromise. This could also come out of some sort of political situation, especially if people grasp the significance of the precedence order. And so you could say, for example, and we call this class of rules, it's just a very simple idea. We just say, well, these are the split DASPR mechanisms where we just split the reserved positions at the beginning and at the end. Okay? And so we have, like in this example, we have 3 reserved positions at the beginning. So those we can think of as not targeted positions. And there are 2 reserved positions at the end, which are targeted. Now you can ask, how can you interpret this? So actually the interpretation is not, yes, okay, so not targeted, targeted. But actually, I think the correct way of interpreting this kind of splitting the reserved positions would be that, so what is my objective if I pick this entity selection rule? So basically, I want at least 5, right? So the total number of reserved seats or reserved positions. So I want at least 5 priority agents matched to this entity, and I want to make sure that 2 of them are targeted. So at least 2 of them are agents for whom this will make a difference, right? Who would not have been picked otherwise. Okay, so that would be the interpretation of choosing such a selection rule. And then, of course, so we can see the targeted positions would be at the end, the non-targeted at the beginning. And of course, this subclass of the DASPR mechanisms, of course, still has the 2 extreme members, the DAMIR and the DATPR, where in the DAMIR, none of the reserved positions are targeted. In the DATPR, all of the reserved positions are targeted. And then we can make I'm sure you can see that we can make the kind of comparisons that we would like to make among these rules. So if, of course, we need to require that this kind of comparison holds for all the entities, right, then we can say that one split DASPR mechanism is more targeted than another. But of course, we can see that it's just simply a matter of switching a few of those R positions from the front to the back or from the back to the front, right? And so these are all comparable. Okay, and then, to finish, so this is actually, the last theorem that I'm going to show you. So this is actually just the generalization of that benchmark comparison theorem that I've shown you, that I showed you. So the DATPR and the DAMIR comparison for the homogeneous profiles also extends to all the rules that are, so it actually doesn't have to be just the split DASPR mechanisms, but so if you have one rule which is more targeted than another, then we can make that same welfare comparison for the priority agents, that if the matching is different at 2 profiles, then the one for the more targeted rule is going to Pareto dominate for the priority agents only, right? It's going to Pareto dominate the matching for the that is selected by the less targeted mechanism. Okay, and so so the takeaways, I'm sure by now you all know this, or it should be very clear. I feel like I'm repeating myself, but hopefully it's not too much. So different priority reserve policies should be evaluated in terms of different objectives: representation, which we can think of as diversity from the EDI, right, versus effective preferential treatment, which we can think of a little bit or more as equity. And the DAMIR is most appropriate if representation is the goal, while the DATPR is most appropriate if effective preferential treatment is the goal. And the class of DASPR mechanisms includes the DAMIR as the least targeted priority reserve policy, while the DATPR is the most targeted priority reserve policy. And this class is characterized by strategy proofness and weak reserve stability. However, not all of these policies, these DASPR policies, make sense, or at least we could make sense out of them. But we recommend a range of policies, the split DASPR mechanisms, which we think are a good compromise because we understand they seem to be more transparent in terms of their impact, in terms of the objective, and also this range allows for flexibility when choosing the extent of targeting for a priority reserve policy. And so to conclude, so again back to EDI, which is here to stay. I just wanted to say that we were able to, in this matching theory context, we were able to pinpoint the difference between diversity and equity, we think, in this very simple model in terms of stability concepts and also different rules. And maybe, I have no idea, I'm just saying this, but anyway, maybe in future work we can also include inclusion. So thank you very much, and thank you for listening to my talk.
My question is about the link, about participation to the mechanism. Oh. So, sorry, the question is about participation in the mechanism from the point of view, for example, of students or people we want to help. And so the link between participation and the trade-off or the comparison between the two principles or objectives you distinguished, so the number of people you want to help and representation, because so at least some people would say that one justification for representation is that actually it conditions how much you can help people, because in a lot of in a lot of problems you want to help people, but people don't apply to the helping mechanism that exists. And so that representation is a way to not incentivize, but to favor their participation to mechanisms. So with in a way, with endogenous participation, maybe MIR as a first step could be in a sequential problem. You could use MIR to enhance, to have a lot of minority students, for example, and then the other one.
Yeah, so I think finally I understand your question. So I think, again, you are, yeah, we presented this paper a few times, and often what comes up is that everyone thinks in terms of affirmative action. So you are thinking in terms of affirmative action, but you see, this would not be an issue, let's say, for refugees. If I'm a refugee from Syria, I desperately just, want to get accepted, by whatever, Sweden, right? So there is no issue of, you are thinking that people may not want to apply because they feel like they are some sort of a charity case. Is that what you are thinking?
I'm thinking, for example...
As opposed to, let's say, if it's representation, it's like, well, yeah, of course, there is a representation. But this is affirmative action you are talking about. But in all these other contexts that we are thinking about, people with some sort of, like from poor socioeconomic background, so it's not an issue.
I was maybe
unless I misunderstood your question.
No, you're right to point out. Maybe I had this in mind, but I had another example, which is not affirmative action, is also social housing, for example. And actually, it's not clear that all people who would need or who could benefit from social housing actually participate into and apply for social housing.
Yeah, but are you saying that if the mechanism uses the DATPR as opposed to the DAMIR, then there will be fewer applicants? Because I don't see that. Actually, what we know in real life, that almost nobody cares about. People don't know what the algorithm is that is being used. At least, yeah, I mean, I'm not exactly an applied person, but for example, I was shocked to see, if you look up the Boston School Choice website, Maybe it changed in the meantime, but when I looked, the algorithm was nowhere to be seen. You could never find out that actually it's a deferred acceptance. There was a lot of stuff about how great this rule is and how you should be reporting your true preferences. You never find out the algorithm. So in this sense, I think whether one algorithm is used or the other in a practical setting, so I think your question is about real-life implementation or, well, I shouldn't use that word, but yeah, so real-life use of these mechanisms. So I don't know if that's if that's really a big issue. Yeah.
Two simple question. Can the prioritized group take the unreserved seat? I was imagining like a train situation.
I'm sorry, I really
A prioritized group can take unreserved seats if you go TPRO?
Yes, yeah. So the priority group agents. So that's the sort of the main idea, the difference between the DA-MIR and the DA-TPR. So in the DA-MIR, they can only take unreserved seats if everyone would qualify without the priority treatment. Mm-hmm. That's why I was emphasizing that effective. So at a first glance, you may not notice, at least, well, I didn't. I'm sure some other people might have, but to me, it took a long time to understand that the DA-MIR policy really effectively puts a cap unless all minority students, so let's say you have 5 seats set aside, you can only have 6 if all 6 of them would have been accepted without the priority treatment. So that means that, I mean, practically speaking, I think in the majority of cases, you cannot go above, but in the DA-TPR you can. So that's a main distinguishing feature. Yes.
I think prioritized group would be happy to take without prioritization.
Yes,
they may increase their seats if you imagine train
I would
situation.
think so, but it's a different issue, of course, what the non-priority agents think about it. But again, that's why I try to emphasize that how you pick the number of the reserved positions should depend on the goal. So it's not necessarily the case, and I'm not advocating going from the DA-MIR to the DA-TPR necessarily with the same number of reserved seats, which we understand that would result in selecting more priority agents. Right? Of course, if that's desirable, then it should be done, right? But I'm just saying. Okay.
Anyone else? Okay, so thank you very much. Before we go, I'd like to say a few more things. 1 minute of thanks to the organizers. I think on behalf of all the participants, I'd like to thank David Cantala, Kanishka Dan, Diego Dominguez, Andrei Gomberg for the superb organization of this meeting in the light of very challenging circumstances. Would like also to, a meeting of this site does not rely only on the main organizers. You need help. And you must have noticed all the students in every room who provided extremely efficient and discreet help with the technology. So I'd like to thank all of them. I would also like to thank Colmax for lending us this beautiful facility. I absolutely love this building. The geometry of it, the way it hints at pre-Columbian architecture, the way it sits in that beautiful natural environment. I just love it. I would love to have a building like this in my university. This is a great, and plus they had very modern technologies that made a very seamless transition between those in-person presentation and the remote presentation. I thought it worked really well, and that's thanks to the very modern technology that was available in every room. I'd like to thank ITAM for providing the transportation, and I also like to, of course, thank the various organizations who have helped us financially, and that Colmax, Colegio México, and CIDE, ITAM, UNAM, the United Nations Programme for Development. Thank you all for coming, and have a safe trip home. Have a safe trip to Paris in 2024. Thank you.
I believe those who've been in contact